Math lesson 118. Multiplication. Here are letters that stand for numbers. The numerator is A, and the denominator is B. The fraction equals 1 whole unit. One possible pair of numbers for A and B is 2 and 2. 2 and 2. 2 halves equal 1. What's another pair of numbers for a fraction that equals 1? It could be any pair of identical numbers. 1 over 1, 2 over 2, 3 over 3, 4 over 4, 5 over 5, and so on. If A over B equals 6, what's a possible pair of numbers for a fraction that equals 6? Some examples could be 6 over 1, 12 over 2, 18 over 3. Because remember, that means divide. 6 divided by 1 is 6, 12 divided by 2 is 6, and 18 divided by 3 is 6. If A over B equals 10, what's a possible pair of numbers for a fraction? An example could be 20 over 2. If A over B equals 20, what's a possible pair of numbers for a fraction? $40 over 2, because 40 divided by 2 is 20. If we multiply A over B by 1, we end up with more than A over B or less than A over B, or a value equal to A over B. So if we multiply A over B by 1, we end up with equal to A over B. If you multiply the numerators, what's the answer? Multiply these two numerators, the answer would be 6A. If we multiply these two denominators, the answer would be 6B. Like so. What can you do to show that 6A over 6B equals A over B? We would cross out the fraction that equals 1, 6 over 6. We can just cross those out, bringing us back to A over B. If you have 1 times A over B, that's A over B. If we multiply A over B by 1, like here, we always end up with a value that equals A over B. If we multiply A over B by a value that is more than 1, we won't end up with A over B. We will end up with something that is more than A over B. Here we have A over B times 7 over 6. Let's say that A over B equals a whole number. We're multiplying the whole number by 7 over 6. 7 over 6 is a top-heavy fraction, meaning it's more than 1. So our answer is going to be more than 1. Let's say A over B equals 12. We multiply 12 by 7 over 6. Let's see if the answer is more than 12. The first thing I want to do is cross divide to reduce these two numbers. Two times 7 equals 14. There's nothing here now, it's just over 1, and this is a 1, so just 14. So we multiply A over B by more than 1. We end up with more than A over B, because we knew A over B equals 12, so we know that 14 is more than 12. A over B times 2/3. If we multiply by 2/3, we end up with less than A over B because this is not a whole or top-heavy fraction. This number is less than 1. Let's say A over B equals 12 again. We multiply by 2/3. First, we want to reduce these two, like so. Remember, this is over 1. Now, 4 times 2 equals 8. Over 1, so it's just 8. And now we know, like we said, our answer is going to be less than A over B, because A over B is 12, 8 is less than 12. So if we multiply A over B by less than 1, we end up with less than A over B. If we want to end up with A over B, we would multiply a fraction that equals 1. So this fraction should always equal 1 if we want A over B to equal A over B, because any number times 1 is itself. Let's say that A over B equals a whole number. If we multiply A over B by a whole number, the answer would always be another whole number. If we multiplied by a fraction that equals 5, we would again end up with a whole number. That number would be more than A over B. How many times more than A over B would the answer be? 5 times. If we multiplied by a fraction that equals 10, would we end up with a whole number? Yes, we would. How many times more than A over B would the answer be? It would be 10 times more. Now we're switching to coordinate systems. We're going to make a line on the coordinate system for 2 rules. Here's the first rule. Add 3. Say the first rule. Add 3. Here are the first numbers for that rule if we start at 0. 0, 3, 6. Each time we're adding 3. The next number would be 9. After that would come 12. Here's the second rule. Add 6. If we start at 0, the first numbers for that rule are 0 and 6. Start at 0, add 6 more, add 6 again, add 6 again. 0, 6, 12, 18, 24. We can show both those rules with a line on the coordinate system. The rule for 3 gives the x values. The rule for 6 gives the y values. The rule for 3 gives x values. The rule for 6 gives y values. X, y, x, y. 3 equals x, 6 equals y. The x and y coordinates for the first point are 0, 0. The x and y coordinates for the next point are 3, 6. The coordinates for the next point are 6, 12. Then 9, 18, 12, 24. Here's the line with the points shown. Each of these points is one of these numbers. 0, 0, 0, 0. Every point shows a value for x and a value for y. The x value for this point is 6. The y value for this point is 12. 6, 12. Right there, right there. So, which is more for this point, the x value or the y value? The y value is more. It's 2 times greater than the x value because 6 times 2 is 12. This coordinate is 12, 24. The x value is 12, the y value is 24. Which is greater? The y value is greater because it's 24. How many times greater is 24 than 12? 24 is 2 times greater than 12 because 12 times 2 is 24. Now open your workbook to lesson 118 and find part 1. You're going to make points for a new pair of rules. The first rule in the box says add 2. The rule in the second box says add 4. You're going to write x and y values for the points. The numbers for 2 will be x values in the column. Start with 0 and add 2 for the other numbers. Do the same for y. Start with 0 and add 4 every time. This is what you should have. Each row shows x and y coordinates for a point. The first point is 0, 0. The next point is 2, 4. After that is 4, 8, and after that is 6, 12. Show the parentheses and commas for the points. Then plot the points and make the line. Pause the video now to do the work and resume when you're ready to check. Here's what you should have. Now let's answer the questions. What's the y value of the point that has the x value of 10? 20. B, what's the x value of the point that has a y value of 12? 6. C, for the points on the line, which is more, the x value or the y value? The y value. D, how many times more? 2 times more. Yes, y is always 2 times x for this line. Let's switch gears to fraction representation. Read this fraction, 18/6. Again, this fraction reads 18/6. We can rewrite 18/6 as 1/6 times 18. We can rewrite this as 18/6 as 1/6 times 18. Now we have 18/6 equals 1/6 times 18. This side is equal to this side. We can rewrite 36/4 as 1/4 times 36. Read this equation. 36/4 equals 1/4 times 36. Your turn. In part A, rewrite 15/5 as a fraction times 15. You should have 1/5 times 15. Now do 38/2. Rewrite that as a fraction times 38. You should have 1/2 times 38. Here's a diagram of 18/3. It shows how many are in each group. How many circles do you see in each group? 1, 2, 3, 4, 5, 6. There are 6 circles in each of these groups. There are 3 groups, and there's 6 in each group. We can show the number in one group as 1/3 times 18. So this row can be looked at as 1/3, because that's 1 out of 3, times 18 in all, because there's 18 circles, equals 6, because there's 6 in one group. Here's 2/3 times 18 equals 12. We went from 1/3 to 2/3 now. So if we have 2/3 of these circles, we have this row and this row, we now have 12. So we know 2/3 times 18 equals 12. Now, How would it look if it was 3/3? It would be 3/3 times 18 equals 18. Remember, this basically equals 1. So 1 times 18 equals 18 because you have one whole here. We'll make diagrams for 20/5. There are 20 objects in all. You'll make 5 groups. There will be 4 in each group because 20 divided by 5 is 4. Like so. There are 4 in each of these groups. The equation for one group is 1/5 times 20 equals 4. Here's the equation for 2/5 times 20. That equals 8. 1, 2, 3, 4, 5, 6, 7, 8, because out of 2 of these you have 2 groups, you have 8 shaded squares. Now write the equation for 4 groups. This is what you should have. Now, if you had 5 out of 5 groups, what would that equation be? 5/5 times 20 equals 20 because it's the whole group. Now please find part 2 in your workbook. Part 2 in your workbook. You're going to make the diagrams to show the answer to each problem. Problem A, 2/10 plus 6/100. Write the answer to the problem. The answer is 26/100. Make the diagram for 2/10 in the top box. Shade rows to show 2/10. Make the diagram for 6/100 in the second box. Show the answer in the last box. Here's what you should have. Here's one way to show 26/100. 2 rows are shaded, that's 20/100. And 6/100 is another row, in another row are shaded. Problem B. Five tenths plus 8/100. Make the diagram for 5/10 in the first box and 8/100 in the second box. Show the answer in the last box. Here's what you should have. 58/100. Now we're going to move on to fraction comparison with unlike denominators. So open your textbook to lesson 118 and find part 1. Problem A, 6/10 and 2/3. Copy the fractions, rewrite both fractions with the lowest common denominator, then complete the original statement. Pause the video now to do the work. Resume when you're ready to check. Here's what you should have. You change the denominator to 30ths. So 6/10 turns into 18/30 and 2/3 turns into 20/30. Which is more? 2/3 is greater. Problem B, 9/4 and 14/6. Pause the video now to work the problem. Resume when you're ready to check. Here's what you should have. 9/4 turns into 27/12 and 14/6 turns into 28/12. Which is more? 14/6. Problem C, 9/15 and 6/10. Pause the video now to do the problem. Resume when you're ready to check. Here's what you should have. 9/15 turns into 18/30 and 6/10 turns into 18/30. So your fractions are actually equal. Now let's move to fraction operations. Read this equation. 1/2 plus 2/10 equals 3/8. Again, 1/2 plus 2/10 equals 3/8. The answer shown is 3/8. I can tell the answer is wrong without working the problem. 3/8 is less than 1/2. And this is an addition problem, so that doesn't work. One half plus 2/10 should be more than 1/2. So the answer must be more than 1/2. It can't be 3/8 because 3/8 is not more than 1/2. Two fifths plus 4/7 equals 5/10. 2/5 plus 4/7 equals 5/10. The answer shown is 5/10. Is that more than half, less than half, or equal to half? 5/10 is equal to half. Is either of these fractions more than half? Yes. 4/7 is more than 1/2. If one of the fractions we add is more than 1/2, could the answer be half? 1/2? No. So could the answer be 5/10? No. 4/7 is more than 1/2, so the answer must be more than 1/2. 9/7 plus 1/5 equals 10/12. Is the answer more than 1 or less than 1? This answer is less than 1. Are either of these fractions that we're adding more than 1? Yes. 9/7 is a top-heavy fraction, meaning it's more than 1. So can the answer be 10/12? No. 10/2 is less than 1, but 9/7 is more than 1. So the answer must be more than 1. Now find part 2 in your textbook. All these problems have an impossible answer. You're going to write a sentence or two that tells why the answer is impossible. So this is your chance to give the reasoning. Item A, 7/8 equals 1/2. 7/8 minus 1/2 equals 8/7. Give an answer of why that answer is impossible. An idea could be 7/8 minus 1/2 is less than 1, but the answer shown is more than 1. Item B, 2/5 plus 7/8 equals 9/20. Why is that impossible? One of the numbers added is more than half, but the answer shown is less than half. Item C, 10/10 minus 4/4 equals 6/6. Why is that answer impossible? So in this, all the fractions equal 1, but 1 minus 1 is 0, not 1. Last time you worked with expressions that multiplied values. This expression says 5 times the quantity 346 minus m. This one says 1/2 times the quantity 346 minus m. Which expression is more? This one or this one? This expression is more. 5 times the quantity 346 minus m. If you multiply by more than 1, right here, you end up with more than what you start with. Is 5 more than 1? Yes, 5 is more than 1. So if you multiply 5 times the quantity, 346 minus m, you'll end up with more than 346 minus m. If you multiply 346 minus m times 1/2, you will not end up with more than 346 minus m. Now find part 3 in your textbook. The value inside the parentheses is the same for all these expressions. I'll read each item. You'll write the answer. Item A. Write the letter of the expression. Hold on. Again, find part 3 in your textbook. The value inside the parentheses is the same for all these expressions. I'll read each item. You'll write the answer. Item A. Write the letter of the expression that has the smallest value. The answer, y. Item B. Write the letter of the expression that has the greatest value. What's the answer? Z. Item C. Write the letter of the expression that are more than 4/3 times the quantity, 1,149 plus 357. The answer? T, V, and Z. Item D. Write the letter of the expression that is 3 times greater than 2 times the quantity, 1,149 plus 357. The answer? Z. Item E. Write the letter of the expression that is less than the quantity, 1,149 plus 357. The answer? Y. Item F. Write the letters of all expressions that are more than the quantity, 1,149 plus 357. The answer? T, V, X, and Z. The quantity 1,149 plus 357 is 1,506. Item G. Figure out what 4/3 times the quantity 1,149 plus 357 equals. The answer? 2008. Item H. Figure out what 1/2 times the quantity 1,149 plus 357 equals. The answer? 753. Your independent work begins now. Independent work is textbook, parts 4 through 11. Reach out to me if you need help. Otherwise, get busy.